Kia ora whanau, welcome to the video which deals with events and Venn diagrams. This is one in a series of videos produced by Maths OSC that deals with the calculus and statistics curriculum in New Zealand. So let's crack straight into it with an example. Here we go. The number of students who play hockey is 16. So imagine we've got a scenario where this is the case. And so there's also another sports team, a netball team, and the number of students who play netball is 19. What we're going to do is we are going to represent this in a picture. The two labels I've given H and N, H for hockey, N and netball, we're going to call them events. So we're going to say either students play hockey or they play netball. So let's draw this in what's called a Venn diagram. You may have heard or seen of a Venn diagram in other subject areas, but the principle is the same. So let's press on, and there's our rectangular box. Now this represents all possible outcomes. So everything that could happen is within this little rectangle here. Here we go. That is the event of students who play hockey. We know that the number that belongs in there is going to be 16. So 16 students playing hockey. Similarly, we have students who play netball. That is the other event. So remember, we've got two events going on here. Also assume that there are 100 students who play sport. So what this will tell us is that if 16 hockey players are available, 19 netball players are available, then 65 students must play other sports. So what we can do from this point forward is we can calculate some probabilities. So we're going to calculate the probability of a student playing hockey. And that equals 16 divided by the total number of outcomes, or the total number of students in this case, which is 100. And as a decimal, that ends up being 0.16. We can also calculate the probability of a student playing netball. So that's going to be 19 divided by all possible outcomes, or the total number of students in this case, and that gives us 0.19. There's one more probability that we can calculate, and that is the probability of students playing other sports. And that's represented by that 65 on the top right corner of the Venn diagram. And end of the day, we get a probability of 0.65. Now, if you were to add these three probabilities together, you will get 1. And that's because we have put on the slide every single thing that can happen. So remember, in this rectangular box called the Venn diagram, we have everything that is going on, or all possible outcomes. Just to add a little bit further to this Venn diagram, these two events, H and N, here are mutually exclusive. What that means in simple terms is either a student plays hockey or they play netball, but they can't play both. So now let's consider a scenario where students do play both, because that can happen. A student can play both hockey and netball, be in both teams. Alright, so we're setting up our example again. and we're going to add in this complication here. 2 students play hockey and netball. So let's draw this out. This is what we had before, hockey and netball. 16 and 19. Now our Venn diagram is not going to look like this. There's a 65 there for you. It is going to look like this. And the reason is because we've got some students who play both hockey and netball. So if you look carefully, that region in the middle, or the part in the middle where the 2 circles cross each other or overlap, that represents the students who play both sports. So now let's label what we've got here, 2. So 2 students who play hockey and netball. Okay, so the blue circle is the total number of students who play hockey, that is 16. But what I want to put in here is this. Now I know 14 plus 2 is 16, so when I add up those 2 numbers there, I will get the total number of students who play hockey. Now that 14 represents the students who just play hockey, nothing else. Similarly, we can do that with netball. So the 17 there represents the students who only play netball and nothing else. So as a little check here, here is some working that I've put down. Now remember, I've added the 2 back to both the students who just play hockey and the students who just play netball. When I total that up, I get 35. And remember, other sports, there's 65 students who play other sports. So we add the 35 and 65 together, we come back to our 100. So that's just a little check for you guys, so you know that every single student is accounted for. And again, the rectangle takes into account everything that is going on. So now what we're going to do on the next slide is we're going to calculate some more probabilities. So here we go, there's our diagram again. And let me speed this up a little bit. Oh, there we go. This is what we had before. And I'm just going to label that 65 as well. Now, these probabilities will stay the same because the event of H, or students playing hockey, there are still going to be 16, regardless of the fact that the 2 students in the middle play netball as well. Same situation for netball. Regardless of the fact that our picture shows that there's 17, remember that 17 represents the students who just play netball. There are also the 2 who play hockey and netball. So we have to add that into our total because that N there represents the event of a student playing netball. So these probabilities stay the same. What we are going to do though is we are going to calculate the probability of this scenario here. A student playing both hockey and netball. Now that should be immediately obvious to you. 2 divided by all possible outcomes, 100. 100 students. Okay, there we go. Oh, I've skipped one too far there. Now I've shaded that area there for you, just so you know where to look. I'm also going to shade in the orange part because I want to show you that this probability here relates to the entire orange circle, including the overlap, the bit in the middle. And then, forgive my shading, it's not very good, but I also want to show you that this probability relates to the entire blue circle, including the overlap. Now that's important, so please remember that. The last probability I want to calculate, before I do that, let's just put the decimal down, 0.02, is this one here. So this probability now, I want to know what is the chance, or what is the probability that a student plays hockey or netball, but not both? So just hockey and just netball. So essentially what I'm going to do is I'm going to take out of the picture that bit in the middle, that overlap, those students who play both sports. So I've already done that in my numbers there on the diagram. So 14 plus 17 is the number of students who play just hockey and just netball. Now that will be divided by now I understand that that's an error there. What that should be is 14 plus 17 divided by 100. And you will get a different probability to 0.8857. I apologize for that. And I have a tick for the 0.02, but the one at the bottom should be a cross. But hopefully it's clear enough that you can work out that you can replace the 35 in the denominator there by 100 and work out your probability. Thank you for watching. Have a nice day.